Okay, Chapter 5 of investments is about risk, return, and historical record. So the first thing we talk about is the holding period return. So this gives the rate of return over a given investment period. So we take our sale price, which means what we sold it for, minus our buy price. So that would be basically the growth or decline that we got out of the stock. So if the stock went up, obviously that would be a positive result, would be a positive number. If stock went down, the result for that particular part of the equation would be a negative number, plus any dividends, if there were dividends, cash dividends, we're not talking about stock dividends. And then we divide that by the buy price. And that should come out to a percentage of what the return for the holding period was. So if we had an example here, what is the HPR for a share of stock that was purchased at 25, sold 27, and distributed $1.25 in dividends? So it would be 25 minus 27, I'm sorry, 25 minus 27 minus 25, excuse me, plus $1.25 in dividends divided by 25 gives us a 13% return for the holding period. Notice that holding period is just how long they owned it, so it doesn't give us me a time frame. So that the problem I personally have with this number is it's not annuitized. So it could be, this could be 13% over, a month. This could be 13% over 2 years. This could be 13% over, how long it is. So that makes this a little, it doesn't make the number not important, but it makes it have a little less gravity to it as far as I'm concerned, because I don't know the time frame that this happened. The capital gains yield, if we are doing capital gains yield, we take out the dividends, only capital gains. So it's the same formula, we just remove this $1.25 and say, okay, now just what did I return just on the capital gains itself? In this case, that's 8%. So the $1.25 made up the other 5. Dividend yield is the other 5%, $1.25 divided by 25. Okay. Measuring returns over multiple periods. This is one I'm a little bit more familiar with. The sum of returns in each period divided by the number of periods would give me my arithmetic average, or my arithmetic average. So the example that it gives in the book, we have assets on table 5.1, where we have $10 or 10% return, and then a 25% return, and then a 20% decline, and then a 20% increase. If we did that and divided by the number of years, just was in 4 years right here, we have the 10%, 25, down 20, and then up 20. If we take that and divide by 4, that's my arithmetic average, which would be 8.75%. Geometric average, we average the quarterly return equal to a single per period return that would give the same cumulative performance as the sequence of actual returns. So effectively, our geometric average, we take 1 plus the return times 1 plus the return for the next year times 1 plus or 1 minus, if it's a negative number, excuse me, the return times 1 plus the return for the 4th year for year 4. So I would do 1.1 times 1.25 times 0.8, 1 minus 0.20 times 1.2 raised to the power of a quarter for the quarterly to get our geometric average of 7.19%. And then there's the dollar weighted average, which is the internal rate of return on the investment. And the dollar weighted average, I take the IRR, and it's the interest rate that sets the present value of cash flows realized in the portfolio equal to the initial cost of establishing the portfolio itself. This one can be done actually in Excel. There's an equals IRR function if you want to use it, but the calculation not done in Excel looks like this. So we're setting it equal to 0, and we're solving for the dollar weighted average. In this case, it's 3.38%. Okay, annualizing the rate of return. Annualizing rates of return. APR is the annual percentage rate. This is the per period rate times periods per year. So if I return 10% in a month, really to convert that to an APR, I need to multiply that 10% times 12 because that was monthly. If I return 10% in a 6-month time frame, so I might say I did my holding period return and I got 10%, but I'd owned the stock for 6 months, then really my APR on that is really 20%, because if it did it in 6 months, that means that if I had an additional 6 months, that would be 10% times 2, which would be 20%. But that does ignore compounding. The effective annual rate is the actual rate an investment grows and does not ignore compounding. So this is where we actually start doing like net present values of cash flows. So for n periods of compounding, EAR is 1 plus the APR over n. Remember, n is the period raised to the power of the number of periods minus 1. Where n is the number of compounding periods. For continuous compounding, we would do e to the power of the APR. Okay, so let's see here. All right, moving on. The nominal interest and real interest. So the real interest rate versus the nominal interest rate is taking into account what our inflation rate is, basically is what we're working on here. So the nominal interest rate is a rate in terms of nominal, not adjusted for purchasing power. The real interest rate is a growth rate of purchasing power derived from an investment. So we're taking into it, when we're doing the real interest rate, we're taking into account inflation. When we're doing the nominal interest rate, we're not. So example, the real return on investment that earns 10% return during a period of 5% inflation is really 4.8%, because the value, that money went up by 10%, but the value of it went down, each dollar went down by 5%. So this is the function here that you see we just used from up here to find that 4.8% is the real interest rate. The nominal interest rate would have been the 10%. Equilibrium nominal rate of interest. The Fisher equation. I'm gonna actually stop this video here and start with this on the next one.